Well, Dinan's always been famous for software. We've been doing software since 1984. And we went to Dinantronics on new cars because with every generation, hacking the encryption in the software gets more time-consuming and more expensive. And we get later and later and later in the production cycle of the car to release products. So we thought it was advantageous for us to make our own ECU, that we knew what the software was so we could get to market sooner. Are we able to do more? No. Software will do anything that Dinantronics will do. It's just an advantage to get into the market sooner. But also what we noticed was, and the reason we like software so much is all the piggyback boxes that we've seen in the marketplace don't do a very good job of controlling all the signals that need to be controlled. And there was always tuning compromises. Where with the software, there was no tuning compromises. So the reason it got so elaborate, wound up with such a big wiring harness with so many signals going through it, so we could correct for everything that needed to be corrected for and have it run like it was software. Yeah, a piggyback box is just basically an ECU that piggybacks on top of the factory ECU and then alters the signals rather than actually taking control of the engine, where this is a complete standalone ECU here. There's no other ECU running the engine. There's just one. And when we had software, we just used the original ECU that came in the car and remapped it, where now we're literally adding a signal modifier is essentially what a piggyback box is. But there's a lot of signals. You can do a more thorough job of modifying those signals or a less thorough job. And the more thorough job you do, the better the drivability of the car is going to be, and the better the performance is going to be, and the better the durability is going to be. Because you have to realize what the ECU does is it compares this signal to another signal and says, okay, do these two values make sense? It's what's called a plausibility test, right? So if I've increased the boost and my boost pressure goes up, my airflow should go up, my air mass meters, and my wastegate signal should change. And my fuel mixture should change, and my ignition timing should change, and my fuel flow should change. Has it really done all those things in equal proportions? Do I believe what I'm seeing? Because the ECU is doing a logic test, basically. And if those signals don't all match, it says, I see a problem. It either will set a fault or go into limp home mode. So the goal in making the car run good is, if you're going to modify one signal, every signal it can compare to has to be changed in equal amount. Well, I mean, all modern engines live in what you would call in the olden days into detonation zone. Even completely stock, they do. And what happens is the computer then will, if it hears too much detonation, will pull the timing back or the boost back or add fuel to try and correct. But you can get into the range where it does what's called adaptation, which is where it's learning how much it's correcting, and it takes those learned values and implements them so it winds up with a smooth curve. Or you can get it to where it can't learn and adapt anymore, and it's in a reactive mode. And when you get into reactive mode, then the engine runs erratically and it isn't as smooth. So what we're attempting to do is modify enough signal so that it's not reactive, it's adaptive, so the overall smoothness of the engine operation is better. This forces you to run just a little bit less boost, and it's not a lot, just a little bit less. Typically, we're giving up about 5 to 10 horsepower from our competition to make the engine run glassy smooth and be durable and not set a fault. Not very much. I mean, you have a M5 that makes 700 horsepower. Does it need to make 705 to run bad? M3 makes, you can make it make 530, so you have to detune it to 521 for it to run smooth. Worth giving up 9 horsepower to make the car run smooth? I think it is. And not just from a durability standpoint, but how nice the car drives. Because it's not just about the ultimate numbers. Is you don't want the car to run erratic. For example, if you raise the boost too much on the M3 when you change gears, there's a load spike, and the knock sensor goes off, and the car falls on its face, and then it picks back up again. Once the detonation goes away, and you shift again, it falls on its face again. And you lose as much time on it falling on its face as you gain by running the extra boost in between, and so the car doesn't really accelerate any faster. You can certainly put it on a chassis dynamometer, you can measure a higher power number, but the car doesn't actually go as fast. So we don't want to compromise the overall speed of the car. The goal here is to make the car not, as fast as possible, but also nice and refined and easy to drive and control, and all those factors are important as well, not just the raw numbers. So if we have to give up 5 or 10 horsepower to make the car run better, we'll do it all day long. Yeah, on the 550, 650, 750 N63 engine, we put intercoolers, intake exhaust, turned the boost up, and put big turbochargers on it. And on the dynamometer, it made more power, but we went on the road. The car was not as fast as we expected it to be. We lowered the boost a pound, and on the data logger on the road, the car went faster. And the reason being is on the road you have ram air, which forces more into the engine. The heat exchanger cools more, the intercooler, and the radiator runs cooler. So the cylinder pressure goes up because we're basically filling the cylinder better. When the cylinder pressure goes up, the knock sensor goes off. When the knock sensor goes off, it retards the timing and slows the engine down. So since the engine was making more power on the road, and we can show you this later on with data logging temperatures on the dynamometer versus the road, it required us to lower the boost because they were making so much boost. The knock sensor was very active, reactive, not adaptive, and this caused the engine to lose acceleration and be erratic in its performance. We backed the boost off a pound, the car actually went faster. So boost pressure doesn't necessarily always equate to more speed. It's a gauge pressure number, right? What we really want is the car to go faster, and sometimes a little bit less boost makes the car go faster than a little bit more. Yeah, we hear a lot that we're conservative. We don't believe we're conservative. What we believe is we tune the engine correctly. Sometimes that forces us, like I say, to make 5 or 10 less. We also are very, very accurate about our measurement of our power numbers, which you're going to see later on as we go through a few more things. And a lot of people have a tendency to exaggerate the numbers or pick the best run. And then we measure their equipment. Again, we've never seen a case where we're not within 10. Oftentimes, when people claim more, we're actually making more than them. We've seen the case where we're actually making more than them. So we're in or about the power other people are making, but with a higher level of refinement and smoothness in the process.